Okay, you have something that looks like this on the back, am I right? Okay, so we're gonna do these together. Separation of variables, general solutions.
Mr. Kruger, mine doesn't have a backside.
Oh.
Mine has a backside. Like we got, yeah.
We got the opposite ones.
Yeah.
Alicia, can you hand these two to there? Because those are the correct ones, I gave them the wrong ones.
Thanks.
Sorry.
It's fine.
Okay.
Thank you.
All right, so implicit differentiation. Let's, Brant, can you do that for me?
Oh no, I'm not ready. No,
What's the derivative of x squared? You know that.
2x,
2x, perfect. Plus
2y,
times what?
dy dx.
Perfect.
Shit, this is what I get wrong.
Equals what?
0.
Perfect. Not a polar bear. That means dy over dx is equal to what? You're gonna subtract the 2x, correct?
Yep,
And that's gonna make it a what?
negative 2x over 2y.
Can I divide by 2?
Yeah,
Are you okay if I write this?
yep, that works for me.
That works for you?
Yeah.
Okay. Do you know what shape this is?
Circle.
Circle. So this is telling me the slope of the tangent line at any point on the circle. I can know x and y, right? It's a nice little kind of, I mean, it's easy. You know, like on this point, oh, you'll have 0, 3. So at 0, 3, you'll have a slope of 0. At 3, 0, you'll have an undefined slope, but it'll be vertical, right? Because you can have tangent lines that look down a circle. All right, I see you doing it. Alrighty, so we're gonna do a thing called separation of variables. And so what I'm gonna do is I'm gonna multiply both sides by y and both sides by dx, and I get this. You should always be multiplying by dx, you should always be multiplying by dy. Never add, never subtract, never divide. Okay? And now I'm going to integrate both sides. Sarah,
Yeah,
you could choose the right side or the left side.
left side.
You're going to choose the left side. Okay, what do you get?
1/2 y squared.
I would get a constant, wouldn't I? Right?
I thought that you wouldn't because they like cancel out.
You are correct. Okay. They'll merge to become, the constant here is not necessarily the same constant over here, but when I subtract that constant, it creates a constant. Okay? Everybody remember that?
Yeah.
Okay, I'll do it. On this side, I'm gonna call it C1.
So
Okay.
you just have a constant on the other side?
Right.
Okay.
Because I'm gonna subtract that C1 from the other constant, and guess what? It'll become a constant.
Alright.
Okay, so that means, let me show I'm gonna get my white out and do this. Okay. If I had used I should have used my new pens and erased.
Yeah, should've.
Equals.
Really should've.
Okay, what am I gonna have on the right side then?
Oh, 1/3 x cubed.
Plus C.
Yeah.
Okay? And so I can multiply everything by 2, would you agree?
Yeah.
Y squared equals 2/3 x cubed plus C.
I'm confused on the C thing again.
Okay, is 2 a constant?
Yeah.
Is C a constant? Did you multiply a constant times a constant?
No, that's not what I'm confused about. I'm confused about the C1, C2.
Oh, okay. Let me back up over here. So I had this 1/2 y squared plus C1 equals 1/3 x cubed plus C2, correct? So I'm gonna subtract that constant because I wanna get y by itself. So C2 minus C1 is just a constant.
Oh, yeah, okay.
That's all I'm doing.
Okay.
And rather than go through all that effort just to get C, I'm just gonna put C on the right side, right? That's kind of what we were talking about before, guys,
Yeah.
right? Okay? So now, I'm going to, how do I get y by itself? I gotta do the what? Zero.
Square it.
With a plus and minus in front,
Yeah.
correct? And that's my general form, Ethan, because it's got that C.
Yeah.
It's kinda like the K. Notice C and K are used a lot in calculus. And V is the shape of the absolute value sign, just saying. All right, over here. What do I call that? Leisha, tell me what to do. I'm gonna have Lucy do 3. Oh, give you a hint, I'm gonna put an equal sign in there. Huh?
1 over y squared times dy equals sin x times dx.
Perfect. Integrate, integrate. What's the antiderivative of sine? Negative cosine. You didn't say negative very proudly, but you are correct. Plus c.
Yes.
What is this over here?
Y to the
I heard, did you say a negative 1 over y?
yes.
Okay, so this is a negative 2, right? You would add 1 to a negative 2, it would become a negative 1, and then you divide by that negative 1, which just means it's negative, correct? All right, so 1 over y is equal to the cosine of x plus c. Would you agree? I see nodding there. Lucy, okay with that? Okay, so y equals 1 over the cosine of x plus c. Grant, does that look okay?
Yeah, it looks good to me.
Okay. You're not lying to me, are you?
No, that one looks good.
Okay, Lucy, you got the hard one.
What? Okay, would you do 1 over y times dy equals 1/2 x squared dx?
Oh, you're right, but right now I'm just gonna write that.
Oh, okay.
You're headed in the right direction, okay? Now I'm gonna integrate. And over here you get what?
1/2 x squared.
Plus c?
Yeah.
What do you get here?
Is that like the L, the natural log of y?
The absolute value of y. Are we doing okay, folks? Okay, so that means y is equal to, what's my base here, Lucy?
Oh.
E, I think you said E, right?
I didn't understand what you were talking about.
Well, isn't,
You got-
this is a
I thought-
log,
yeah, I didn't
isn't
realize
this
that you were
log
talking
base E?
about- Yeah, I was
Okay.
thinking like music base. I don't know. That's what I was feeling.
Music base
Yeah.
or bass? Okay, okay, what's my exponent?
Why? Or no?
Let me review. Let's say I had this, log base 3 of 9 equals 2. That means 3 is my base, 2 is my exponent, 9 is my answer, right?
So it would be like the whole like 1/2 x squared plus c.
1/2 x squared plus c, perfect. Okay, so that's the same as this. Would you agree, Lucy? Because when you multiply things that are in exponential form and the bases are the same, you add the exponents, correct? Now, I got a whole bunch of, 2 of the 26 letters of the alphabet right here. E is a constant. C is a constant. So when you take a constant to a constant power, you get a
Constant.
constant. So a lot of times, I can't remember if we wrote B or E, it doesn't matter, or B or C, it doesn't matter. That's my final answer. And I think last year, did I show you that we skipped to that line? You remember that, Ethan?
Yeah. Isn't that like some?
We doing okay on that?
Yeah.
You remember that? It was a long time ago, 6 months ago. Not as nearly as, maybe not 6 months, maybe 4 and a
I
half.
remember this.
You remember that?
Yeah,
Okay, good, because this one's yours. Brad, what are we gonna do on this one? We're done at quarter after, aren't
Yeah.
we? Maybe?
No, it's a quarter.
Okay. What are we gonna do on this one?
You know, Kruger, I'm not quite sure yet.
Can we factor?
You can take out like a 2x.
Okay, let's take out 2x. Because that's basically all we can do right now, right? Because I can't subtract the 4x, I can't subtract the 2xy, so I'm gonna take out a 2x, you said?
Yeah.
And you get y plus 2? Okay, did that help?
Possibly.
Okay. Equal sign,
Now we got,
dy is over here. Dx is over here. Would you agree?
yeah, so you got 1 over.
1
y
over
plus-
what?
Y plus 2,
Perfect.
dy.
Yep.
And you
What?
got-
2x over here.
Yeah. And
Integrate. What's the antiderivative of 2x?
x squared.
Plus,
C.
what's the antiderivative of 1 over y plus 2?
I have no idea.
Okay, let's go look at this. When we had 1 over y, she said it was a natural log.
Yeah. Like what with 2?
Well, just add it to the y.
Is it just ln of y plus 2?
Y plus 2, yeah.
Work.
Wait, Kruger, when did you hit? Isn't this when you like hit your gong last year? Was this it?
You missing me hitting my gong? You want me to hit my
I
gong?
forgot. Like, isn't that you hit it like at some time like this, right?
Oh, it had to do, yeah. Okay, now I remember. Yeah, you're remember really good. I'm gonna do this. That has an exponent of 1, correct?
Oh yeah.
Right?
Yeah, I remember this.
Okay, why do I do that? I can't, you don't want me, he's gonna be so grumpy in 10 minutes. So, that, because if you add 1 to a negative 1, you get 0. And then we would have to divide by 0, and that's why the gong goes up. We can't do that, so that's why we use natural log, okay? That's our first thing, okay? And then, if you take a look, when I take the derivative of this, y plus 2 goes on the bottom, and the derivative of y would go on top, which is 1 dy dx.